going to talk about one of the classical methods in analytical chemistry. It is a volumetric method used to identify the concentration of our substances. We call this titration. Okay, so let's have a walkthrough on how does this work and what to expect. Okay, so titration is a volumetric analysis. So that means we are more concerned on the volumes of our substance reacting to complete the reaction. Okay, so that means I'm going to have my substance here, another substance here. Then I'm going to add this substance into this flask. Then I'll see until I can say that the reaction is complete. This is usually observed using chemical indicators. So one of the most common titration method is the acid-base titration. For example, we have here an unknown substance here and a known substance here. If we react the two together, they will react until they reach this point. We call this the equivalence point. Later on we'll talk about that. Okay, so the idea is that you're going to react the substances in here and in here in this setup until you reach the point at which the reaction is complete. Okay, so let's go into some of the jargons to be used. Analyte, these are substances without known concentration or identity. So these are substances to be analyzed, hence we call them analyte. Analytes are to be analyzed. To be analyzed. Okay. So for titrant or the standard, these are substances with accurately known concentration. So this is the substance that we react against our analyte, so that we can identify their identity or concentration whatsoever. So indicator, these are molecules or these are substances that produce colors at certain pH or certain conditions. This is usually helpful to identify if the acid-base reaction is complete. If you don't have a pH meter, you can use a chemical indicator anyway. For example, in acid-base titration, for strong acid, strong base titration, usually the endpoint is around 7, which you will see the solution turns from colorless into a faint pink color. Okay, so that means that's the end of the reaction. Okay, what else? So we have equivalence point. So this is the point at which the reaction is complete. This is also computed using stoichiometry. Okay, so when we say equivalence point is the actual end point of the reaction. That means at this volume, the reaction is already complete. Okay, and how are we going to compute for that? We use stoichiometry. Okay, so that means you have to know the stoichiometry of your analyte and your titrant. Okay, so for endpoint, this is an estimate of the position at which the equivalence point is observed. Okay, why do we have endpoint and equivalence point? Okay, so we cannot see in our own bare eyes the equivalence point without using indicators. So indicators, they indicate if the titration is at the endpoint. And what do we know about endpoint? This is related somehow to equivalence point. It estimates the position of the equivalence point. Okay, so this is something that is observed by experiment. This is something that is observed by doing stoichiometric calculation. Okay, the difference between the two is not so big, so we can approximately say that the endpoint is almost the equivalence point. Okay, so without without the aid of indicators, we will not be able to identify if we reach the endpoint already, nor it will not give us an idea about the equivalence point. So Yeah, so those are the jargons to be used in titration: analyte, titrant, indicators, equivalence point, and the endpoint. Okay. Okay, so in calculating titration problems, we have to know the stoichiometric coefficients of our substances. Okay, when I say stoichiometry, we are dealing with the moles of substances. And we have ways to solve for the moles of our substances. One way is by the mass relationship. Um, the moles of substance A can be computed as the grams of substance A over its molar mass, or the molecular weight. Okay, so this is one way to express the moles of our substances in terms of mass relationship. The other one is in terms of the volume relationship, which is the molarity of your solution times the volume, of course, in liters. Okay, by multiplying those, you can solve um, for the moles of your substance. Okay, if you have hard time remembering this, you can always use a triangle. Um, this triangle, this is the moles, this is the grams, this is the molar mass. Okay, so if you are looking for the moles, that means you have to divide grams by molar mass. If you're looking for the molar mass, it means you have to divide the mass by the moles. If you're looking for the grams of your substance, you have to multiply moles and the molar mass. Okay. Okay. So another triangle we can use is in terms of volume. This is mole, molarity rather. Okay. So if you're looking for the molarity of substance, you have to divide moles by volume. If you are looking for moles of substances, you have to multiply molarity and volume. And if you are looking for volume, you have to divide moles by the molarity. Okay. So those are some of the basic equations, and the rest is just stoichiometry anyway. Okay. So other helpful formulas. Okay. So this one is an expanded molarity equation. Remember that molarity is mole per volume. What I did here is that I expressed the mole in terms of grams per molar mass. Okay, so and another helpful equation is the dilution equation: C1 V1 over equals C final over V final. So yeah, there you go. This is a dilution equation. We can use this, and the molarity equation, which is just expanded. Anyway, okay. So what else? It is important for you to know the chemical reaction. Okay, so of your substances, because if you are unable to know or if you are unable to establish the chemical relationship of your substances, it will be very hard for you to do titration, because titration requires stoichiometry. This requires stoichiometry. So if you can't have, or if you can't establish the stoichiometry, you cannot do the titration. So you have to know what are the reaction that is going to happen, how to express that in terms of chemical reaction whatsoever. So because that is important, because in stoichiometry, remember, we are talking about the moles of the substances, so it is very important. Okay, so I will answer the exercise problems on the next video anyway.